Hello everyone, welcome to Apex. This is Deepak Nemani, your LRDI mentor at Apex. So in the part 1 of this video, I had analyzed LRDI section of CAT 21 slot 3 and I had also solved 2 sets out of the asked 4 sets. Now if you had not watched that video yet, I will be providing the link of the video in the description below. Now in this video, I will be solving the other 2 sets. Now before we dive into this video, if you find this video useful, please click on the like button. For more videos of this kind, please subscribe to our channel and please share this video with your friends who are preparing for CAT. So without any further delay, let's get started. Now coming to set 2. Each of the bottles mentioned in this question contains 50 ml of liquid. The liquid in any bottle can be 100% pure content or can have certain amount of impurity. Visually, it is not possible to distinguish between P and I. There is a testing device which detects impurity as long as the percentage of impurity in the content tested is 10% or more. For example, suppose bottle 1 contains only P and bottle 2 contains 80% P and 20% I. If content from bottle 1 is tested, it will be found out that it contains only P. If content from bottle 2 is tested, then the test will reveal that it contains some amount of I. If 10 ml of content from bottle 1 is mixed with 20 ml content from bottle 2, the test will show that the mixture has impurity and hence we can conclude that at least one of the two bottles has I. However, if 10 ml of content from bottle 1 is mixed with 5 ml of content from bottle 2, the test will not detect any impurity in the resultant mixture, hence you cannot have a definite conclusion. So this is a question from quant based reasoning, that too from mixtures. Right, and we are asked 4 independent questions based on the given data. Right, now when you are asked independent questions based on the given data, our approach should be question specific approach. That means you need to solve questions one by one. Now coming to question 1, 5 ml of content from bottle A is mixed with 5 ml of content from bottle B. So we have two bottles A and B, each containing 50 ml of liquid. So this is mentioned in the first statement of above paragraph. Right, so 5 ml of liquid from bottle A is mixed with 5 ml of liquid from bottle B. So the resultant mixture when tested detects the presence of I. So we have 10 ml of resultant mixture. When this is tested for impurities, it is positive. That means impurities are present in this mixture. Now if it is known that bottle A contains only P, so there are no impurities in the liquid from bottle A. Right, now what best can be concluded about the volume of impurities in bottle B? Now when you test this liquid, this is positive for the presence of impurities. That means the impurities in this mixture should be greater than or equal to 10% of the volume. Now what is 10% of 10 ml? 1 ml. So there should be at least 1 ml of impurities in this mixture. Right, so the volume of impurities should be 1 ml or more. Right, and all these impurities should be from liquid in bottle B. Right, so this 5 ml contains impurities of 1 ml or more. Now if 5 ml liquid is containing impurities of 1 ml or more, right, then 50 ml of this liquid will be containing impurities of 10 ml or more. So the answer for this question should be option C. Now coming to second question. There are 4 bottles. Each bottle is known to contain only P or only I. They will be considered to be collectively ready for dispatch if all of them contain only P. In minimum how many tests is it possible to ascertain whether these 4 bottles are collectively ready for dispatch or not? Right. Now let these 4 bottles be 1, 2, 3 and 4. Now each bottle is known to contain only P or only I, only 100% pure liquid or only 100% impure liquid, right? So only P or I, similarly P or I, P or I, P or I. Now they will be considered to be collectively ready for dispatch if all of them contain only P. Now if we have at least one bottle containing 100% impure liquid, they are not collectively ready for dispatch. Now in minimum how many tests is it possible to ascertain whether these 4 bottles are collectively ready for dispatch or not? Or I can put this in another terms, like what are the minimum number of tests required to ascertain if we have at least one bottle containing 100% impure liquid or not? Right, now for that let me consider equal volume of liquid from each bottle, 10 ml, 10 ml, 10 ml and 10 ml. So let me consider out of these 4 bottles, 3 bottles contain 100% pure liquid, where you have 1 bottle containing 100% impure liquid, right? So the total volume of this resultant solution will be 40 ml, out of which this 10 ml is the impure liquid. So the percentage of impurities in this resultant mixture will be 10 by 40 into 100, which is 25%. Now, even if we have at least one bottle containing 100% impure liquid, the percentage of impurities in the resultant mixture will be 25%. And if you test that resultant mixture for impurities, it will be positive. So you need to perform test only once by forming a resultant mixture of taking equal volumes from all these 4 bottles. So the answer for this question should be 1. Now coming to third question. There are 4 bottles. It is known that 3 of these bottles contain only P, while the remaining one contains 80% P and 20% I. What is the minimum number of tests required to definitely identify the bottle containing some amount of I? Now let these 4 bottles be 1, 2, 3 and 4. Now let the liquids in bottles 1, 2 and 3 be 100% pure liquids, whereas liquid in bottle 4 has 20% of impurities. Right? Now we need to find the minimum number of tests required to definitely identify this bottle. Now for that, let me consider equal volumes of liquids from these 4 bottles: 10 ml, 10 ml, 10 ml and 10 ml. Now there will not be any impurities in these 3 liquids, whereas you will be having an impurities of 2 ml from this liquid. Right? Now if I mix these 2 liquids to form a resultant liquid of 20 ml, now you will be having 2 ml impurities in these 20 ml of resultant liquid, and the percentage of impurities will be 2 ml by 20 ml into 100, which is nothing but 10%. Now if this 20 ml resultant liquid is tested for impurities, the test will be positive, right? So if you had identified this, I will be grouping these 4 liquids into 2 liquids. I will be adding these 2 liquids to get a resultant of 20 ml liquid, and these 2 20 ml liquid. Now I will be testing this liquid for the presence of impurities. Okay. Now after performing one test, this will not be giving us any presence of impurities, then I will be sure of having that impure liquid in either bottle 3 or bottle 4. Right? Now let me check for the liquid in bottle 3. Now if this is negative, the impure liquid is in bottle 4. And if I check for bottle 4 first, and I will directly get to know the bottle containing the impure liquid. So in any of these cases, I need 2 tests to find the bottle containing the impure liquid. Right? Now instead of checking for the presence of impurities in this liquid, if I consider this liquid first, right? Now if I test this liquid first, this will give us the presence of impurities. Right? Now if that's the case, after performing one test, I'm sure that the impure liquid is in either bottle 3 or bottle 4. Now to definitely identify the bottle containing impure liquid, you need to perform one more test. So in any of these 2 cases, you need minimum 2 tests to definitely identify the bottle containing impure liquid. Now moving ahead to fourth question. There are 4 bottles. It is known that either 1 or 2 of these bottles contain or contains only P, while the remaining ones contain 85% P and 15% I. What is the minimum number of tests required to ascertain the exact number of bottles containing only P? So you can have either 1 bottle containing pure liquid or 2 bottles containing pure liquid. So the remaining 3 bottles in this case will be having impure liquid containing 15% of impurities, whereas here you will be having only 2 bottles. Now let me consider equal volumes of liquids from these 4 bottles: 10 ml, 10 ml, 10 ml and 10 ml. Right? So the resultant mixture will be 40 ml. Now if we have 3 bottles containing liquid with impurities, you will be having 1.5 ml of impurities in this bottle, because 15% impurities. Right? Similarly 1.5 ml impurities here, 1.5 ml impurities here. So in total you have 4.5 ml of impurities out of 40 ml of the mixture. Right? And into 100. So this is obviously greater than 10%. So when you test this 40 ml of the resultant liquid for the presence of impurities, the test will be positive, right? Now if I consider the second case where you have two bottles containing pure liquid and two bottles containing impure liquid, right? Now if that's the case, we have a resultant mixture of 40 ml, and you will be having 1.5 ml of impurities in this liquid and 1.5 ml of impurities in this liquid. So in total you have only 3 ml into 100. So this is less than 10%, and when you test this resultant mixture for the presence of impurities, the test will be negative. So you only need one test to ascertain the exact number of bottles containing only P. You need to test that mixture for the presence of impurities. If that is positive, you have only one bottle containing pure liquid, and if that test is negative for the presence of impurities, you have two bottles containing pure liquid, and this completes the set. Now moving ahead to the last set, set 4. So here we have 10 players, P1, P2, so on till P10, competed in an international javelin throw event, and the number after P of a player reflects his rank at the beginning of the event, with rank 1 going to the topmost player, right? So P1 means he was the rank 1 player initially. There were two phases in this event, with the first phase consisting of rounds 1, 2 and 3, and the second phase consisting of rounds 4, 5 and 6. A throw is measured in terms of the distance it covers in meters up to 1 decimal point accuracy only if the throw is a valid one. Right now, if you look at the first table, the distance covered in by all these players are up to 1 decimal point only, 82.9, 81.5, so on till 84.1. Now for an invalid throw, the distance is taken as 0. Now a player's score at the end of a round is the maximum distance of all his throws up to that round, right? Now for example, let us consider some player in these 3 rounds. Okay, here he had thrown a distance of 90 meters, here let us say 92 meters, and here let the distance be 85 meters. Now his score till round 3 will be maximum of all these 3, which is 92 meters. Right now, players are re-ranked after every round based on their current scores. So now players are re-ranked after every round based on their current scores. So the ranks of these 10 players are not constant. They might change round to round. Now in case of a tie in scores, the player with a prevailing higher rank retains the higher rank. This ranking determines the order in which the players go for the throws in the next round. Now in each of the rounds in the first phase, the player throw in increasing order of their latest ranks. For example, if I consider the first round, so you will be having P1 throwing first, P2 second, P3 third, so on till P10. Now if you observe, in this table we have P7 throwing the javelin to a maximum distance, which is 87.2. So his rank will be 1 for the second round. So he will be throwing first in the second round. Right, and in the first phase the throws are in the ascending order of the ranks. Right now, that is player ranked 1 at that point throws first, followed by player ranked 2 at that point, and so on. Now the top 6 players at the end of first phase qualify for the second phase. So after 3 rounds, the top 6 players will be qualified for the second phase. In each of the rounds in the second phase, the players throw in decreasing order of their latest rank. So you will be having 6 players qualifying for the second phase, right? So let me consider P6 as the player with the least rank who was qualified for phase 2. So P6 will be throwing first, then P5, then P4, and so on in the decreasing order of the ranks, right? Now the players ranked 1, 2 and 3 at the end of 6th round receive gold, silver and bronze medals respectively. Now all the valid throws of the event were of distinct distances as per stated measurement accuracy. The table below shows distances in meters covered by all valid throws in the first and the third round in the event. We are given with distance covered by all the valid throws in the first round, distances covered by all the valid throws in the third round. So that means leaving 1, 3, 5, 6, 7 and 9, the remaining players 2, 4, 8 and 10. So their throws are invalid in the first round, and we are also given with additional 5 statements. Now let's look at those statements also. The following facts are also known. Among the throws in the second round, only the last 2 throws were valid. right? Now both the throws enabled these players to qualify for the second phase, with one of them qualifying with the least score. None of these players won any medal. Now we are not given with any data with respect to second round, but it is mentioned that among the throws in the second round, so you'll be having all the 10 throws, only the last 2 throws were valid, so all the remaining throws were invalid. So you have only 2 valid throws in the second round. Now both the throws enabled these players to qualify for the second phase. So that means the 2 players who had valid throws in the second round were among the top 6 after phase 1. Right now, none of these players won any medal. So these two players did not win either gold or silver or bronze medal. Now coming to second statement, if a player throws first in a round and he was also the last to throw in the previous round, then the player is set to get a double. Now 2 players got a double. Now let's understand what is a double. Now for that, let us assume player P10. Right now he was the last to throw in round 1. Now for example, let us assume that he had thrown a distance of 88 meters in the round 1, right? So that was the highest, so he will get a chance to throw first in round 2. So P10 will be throwing first in round 2, right? Now this is called as double. Okay, so in this round he was the last person to throw the javelin, whereas in the next round, in the immediate round, he was the first person to throw the javelin. So this is called as a double, and the player is set to get a double. Now 2 players got a double. Now coming to third statement, in each round of the second phase, exactly 1 player improved his score. Each of these improvements was made by the same amount, right? Now what do I mean by improving someone's score? For example, let me consider a player who had a score of 92. Okay, let me consider this example only. Okay, now 92 in round 3. Now in round 4, if we had thrown a distance of 94 meters, then his score would have been 94 meters after round 4. Now this is known as improvement, and exactly 1 player improved his score in each round of the second phase. Right, so in round 1 you have exactly 1 player improving his score, same for round 5 and for round 6. Now each of these improvements was by the same amount only. Now if you have someone improving his score by 1 meter, or remaining players who had improved their scores should also had an increase of 1 meter. Now coming to fourth statement, the gold and bronze medalists improved their scores in the 5th and the 6th rounds respectively. Right, now 1 medal winner improved his score in the 4th round. Now we have gold and bronze medalists improving their scores in 5th and 6th rounds respectively. So we have the winner improving his score in the 5th round and the bronze medalist improving his score in the 6th round. Now 1 medal winner improved his score in the 4th round. Now I had made a mistake here when I was solving this for the first time. Right, now 5th statement, the difference between the final scores of the gold medalist and the silver medalist, as well as the difference between the final scores of silver medalist and the bronze medalist, was 1 meter. So if we have a gold medalist throwing a distance of 92 meters maximum, okay, silver medalist would have thrown by 91 meters and the bronze medalist distance would be 90 meters. So there should be a difference of only 1 meter in the final scores of these 3 winners. And we are asked 6 questions based on the data that is given to us. So it's very important to understand this data prior to solving this set. Now moving to solving this question. So in round 1, the order of the throws will be P1 first, P2 second, next P3, P4, P5, P6, P7, P8, P9 and P10, and we are given with the valid throws in round 1. So P1 score would be 82.9, P2 it's not a valid throw here, P3 81.5, P5 86.4, then P6 82.5, P7 87.2, then P9 which is 84.1. Now let me arrange these scores in the decreasing order. So first would be 87.2, then we have 86.4, then we have 84.1, then we have 82.9, then 82.5 and 81.5. Now this is P7 score, 86.5 is P5's, 84.1 P9's, 82.9 this is P1, 82.5 it is P6, and 81.5 is P3. Now after round 1, P7 will be the player with rank 1 because P7 score is the highest. So you have P7 throwing first in round 2, followed by P5, then you have P9, then you have P1, P6, P3. Now we are left with P2, P4, P8 and P10, and all these 4 players had invalid throws in round 1. If that's the case, P2 will be the 7th person to throw the javelin in round 2, then followed by P4, P8 and P10. Now in round 2, it is mentioned that only 2 persons, okay, the last 2 throws were valid. So the throws of P8 and P10 were valid. Now both the throws enabled these players to qualify for second phase. So that means the scores of P8 and P10 are among the top 6 scores, right? Now with one of them qualifying with the least score. So between P8 and P10, you have one person being in the 6th position, and none of these players won any medal. Right now, all the throws in round 2 of P7, P5, P9, P1, P6, P3, these are invalid, so zeros. Now P8 score should be greater than 82.5 because in order to have P8 and P10 in top 6, the distance thrown by these 2 players should be more than 82.5. Then only you will be having P8 and P10 in top 6. So this should be greater than 82.5. Right now in round 3, we have P1 scoring 88.6 meters, which is greater than his previous score 82.9. So P1 score after round 3 will be 88.6. Now if I consider P3, his score in round 3 is 79, which is less than 81.5. So P3's final score after round 3 will be 81.5 only. Whereas P9's, it's 84.1 in round 1 and 81.4 in round 3. So we'll be sticking to 84.1 only. Right now we have the 6th person being either P8 or P10. Now and these 5 persons will be one person between P8 and P10, the other person. Then you will be having P1, P7, P5 and P9. And I can say that P3 and P6 were not qualified for phase 2. Now after round 3, the player with rank 1 can be one between P8 and P10, or that person can be P1 as well. Right, and the second person between P8 and P10 will be ranked 6th. Now after round 3, we will be having either P8 or P10 being the 6th ranked person. Now coming to statement 2, if a player throws first in a round and he was also the last to throw in the previous round, then the player is set to get a double. Now 2 players got a double. Now if I consider the top 6 players after round 3 as 1, 2, 3, 4, 5 and 6. Now in round 4, you will be having this person throwing first. So it will be 6 followed by 5, then 4, then 3, then 2, and the person with rank 1 after round 3 will be throwing the javelin last. Right? Now it is also given that in each round of the second phase, exactly one player improved his score. Each of these improvements was made by the same amount. So we'll come to this point later, but we have one player improving his score in round 4, one in round 5 and another in round 6. Now the gold and bronze medalists improved their scores in the 5th and 6th rounds respectively. So you have the gold medalist improving his score in round 5 and bronze medalist improving his score in round 6. Now one medal winner improved his score in 4th round as well. So most of the students consider this person to be the silver medalist, but it is not mentioned that the other medalist, the other medal winner improved his score in the 4th round. No, it is not mentioned that way. Now we have a medal winner improving his score in 4th round. Okay, so this need not be the silver medalist. Because when I was attempting this question for the first time, I had considered the person who had improved his score in 4th round as silver medalist. No, but at the end, I did not get a definite possibility satisfying all the statements. Right? Then I get back to each and every statement. Then I realized that I had made a mistake here. Now it is given that one medal winner improved his score in the 4th round. So that can be either gold medal winner or bronze medal winner or silver medal winner. Now you have 3 possibilities for that person. That person need not be the silver medalist. And it is also mentioned that none of these players won any medal. So we do not have P8 or P10 winning any medal. So if that's the case, now in rounds 4, 5 and 6, you cannot have either P8 or P10 improving their scores. So that means if this person is P8 or P10, he will be ranked 6th in all these 3 rounds. Okay, his rank will not be improved, right? And if that's the case, you will be having that person throwing first in rounds 4, 5 and 6. So there is no possibility in rounds 5 and 6 for any player to get a double. But it is mentioned that 2 players got a double. One player is either P8 and P10, that is between rounds 3 and 4. Okay, and the other player would have got a double in rounds 2 or 3. We do not know that, but it should be in rounds 2 or 3. Now, can we have a player getting a double in round 2? No. Because the last person to throw the javelin in round 1 is P10 and the first person to throw in round 2 is P7. Whereas we have P10 throwing last in round 2 and you can have P10 throwing first in round 3. So this is possible. Okay, now this is where we have another player getting a double. Now we have P10 being the first person to throw the javelin in round 3. Now in round 3 we have P10 being the player with rank 1. Whereas we have P1 improving his score in round 3. So if that's the case, if I have to arrange these 6 persons in the increasing order of their ranks 1, 2, 3, 4, 5 and 6. Now this will be P8 for sure. Now the player with rank 1, that can be either P10 or P1. Since P1 had improved his score in round 3. Okay, so in one case let me consider P10 being the player with rank 1. So if that's the case, this will be P1, this will be P7, this will be P5 and this person will be P9, right? Now we can also have P1 being the player with rank 1 after round 3. Okay, so if this is P1, this should be P10, then P7, then P5, then P9 and P8. Now it is mentioned that none of P8 and P10 won any medal. So you cannot have P10 winning any of these 3 medals, right? Now if I consider the first scenario, you need to have 3 players out of P1, P7, P5 and P9 scoring more than P10 in rounds 4, 5 and 6. Now if I consider the second scenario, you need to only have 2 persons scoring more than P10. Now it is given that in each round of the second phase, exactly 1 player improved his score. Each of these improvements was by the same amount. Now the gold and bronze medalists improved their scores in the 5th and the 6th rounds respectively. One medal winner improved his score in 4th round. The difference between the final scores of the gold medalist and silver medalist, as well as the difference between final scores of silver medalist and bronze medalist, was 1 meter. So if the final score of gold medalist is X, the score of silver medalist should be X minus 1 and the bronze medalist should be X minus 2. Right? Now let me list down the scores of P1, P7, P5 and P9. Okay, now this is 88.6. Now this is 87.2. Now this is 86.4 and this is 84.1. Now whereas the score of P8 should be greater than 82.5 and less than 84.1. And similarly in this case we have P1 scoring 88.6. We do not know P10 score. P7 score will be 87.2. P5 score is 86.4 and P9 score is 84.1. Now if I observe the difference between these scores 88.6 and 87.2, so this is 1.4. Now the difference between these two is 0.8. Now 86.4 and 84.1, the difference is 2.3. Now similarly this difference is 1.4. Now this difference is 0.8 and this difference is 2.3. Now let us understand a small concept of arithmetic progression here. Now let me consider 3 terms A, B and C. Now let me add same value for all these 3 terms. Let the value be K. So A plus K and plus K. Now the 3 terms now become A plus K, B plus K and C plus K. Now if it is given that the final 3 terms A plus K, B plus K and C plus K are in arithmetic progression, that will be only possible when A, B, C are in arithmetic progression. right? Now similarly it is given that the difference between final scores of gold medalist and silver medalist as well as difference between final scores of silver medalist and bronze medalist was 1. So these three are in arithmetic progression, and it is also mentioned that each of these improvements was made by the same amount. Now these values should have been increased by same amount, right? Now if that's the case, we do not have three values being in arithmetic progression, and if that's the case, you cannot have three persons improving the scores in phase 2, right? So the gold and bronze medalists improved their scores in 5th and 6th rounds respectively. One medal winner improved his score in the 4th round, and that medal winner can be either a gold medal winner or a bronze medal winner as well. If I consider there are only two persons improving their scores, in this case, in the first scenario, you will be having P10 getting some medal. It can be either gold or bronze or silver. But as per the first statement, you cannot have P10 winning any medal, because you can have only two persons out of these four, P1, P7, P5 and P9 improving their scores. So if you have only two persons improving their scores, in the worst case scenario, you will be having P10 receiving a bronze medal, right? So this is not possible. Now, whereas in the second case, among these three persons, P7, P5 and P9, you can have two persons improving their scores. So that can be P7, P5 or P5, P9 or P7, P9. Right? Now, if that's the case, P1 should have received either gold medal or silver medal or bronze medal. Now let me assume P1 had won a gold medal. So the highest score should be 88.6. The silver medalist should have scored 87.6 and the bronze medalist should have scored 86.6. Now can we have person getting bronze medal scoring 86.6? That is not possible. The reason being, I know that P10 score is greater than 87.2 because his rank is better than P7's rank here. Now if P10's score is better than 87.2, you cannot have some other person with 86.6 as his score receiving a bronze medal. So you cannot have P1 winning a gold medal. Now you can have P1 winning a silver medal. So if we have P1 winning a silver medal, if this person's score is 88.6, the person who had won a gold medal, he should have scored 89.6 and bronze medal 87.6. Now we need to check. Now if we have any person scoring a total of 89.6. Now the difference between 89.6 and 87.2, okay, that is 2.4. And the difference between 87.6 and 86.4 is 1.2. Now if you observe, you can have P7 improving his score twice by a margin of 1.2. 1.2 in one round, 1.2 in another round. So improvement is 2.4, and you can have P7 winning a gold medal. You can also have P5 improving his score by 1.2. Okay, so 86.4 plus 1.2, which is 87.6, and winning a bronze medal, and P1 winning a silver medal. Right? And this is the only possibility which satisfies all the given statements. And you need to do this much to solve this question in the exam. So I consider this question to be very difficult because this statement, one medal winner improved his score in the 4th round, is very much misleading, and students might waste lot of time in the exam sticking to the silver medalist improving his score in 4th round. Now I believe that to get a good score in LRDI section, you need to know which sets to pick and which sets to leave. Now that's the key in getting a good score in the LRDI section of CAT. Leave these type of questions in CAT unattempted without any hesitation, guys. Now let's stop here. In the next video, I will be solving LRDI section of CAT 22 slot 1.